Hello, welcome to another Learn to Code, Code to Learn. So this episode, it's Scala. And yeah, this was hard. So if you want to know the premise for this series, then I suggest you watch the very first episode, or episode 0, I think, as I called it, maybe. And you know, all of these series, when I start learning to code, my starting point is always the 7 languages in 7 weeks book and the particular chapter. So I sort of start off with my week 1 is doing the 3 days in that from that book, and then I expand out from that. So the second week is when I record this video and consolidate what I've learned. But as I subsequently found out, you know, things have moved on a lot since, not surprisingly, I suppose, since the book was originally published, and it's something I was expecting anyway. But yeah, this sort of week and a bit, I came down with a bit of a crash in terms of just realizing the chasm that had potentially opened up, and what it led to was me, not surprisingly, leaning in a lot more into code suggestion tools and Copilot type things, only for it to produce Frankenstein code, because it was producing something between Scala 2 and 3, which would run fine in the Scala 3 environment that I had set up, but just in terms of providing a good set of code snippets to show, I figured it would be confusing. So I've just sort of spent most of the day prior to shooting this video going through and double checking all my code snippets, just to make sure that they're a bit more in keeping with Scala 3, but I'm sure there's going to be mistakes. Anybody that knows Scala 3 intimately will probably pick out. So anyway, just a heads up there. I've done a pass through and reran all the code and with all the changes I wanted to make. So we'll see how we do. So let's go through, and I'm going to reflect on while I'm doing this what I've been learning, what I chose to include in this particular episode, and the sort of trials and tribulations that I was facing. Certainly my coding servitors, Socks and Yowley here. It was a challenging week for us. So, what can we say about Scala to start with? So, created by Martin Adersky. Design of it began in 2001 at the EPFL. And it was a follow-on from his work on Funnel, a programming language that combined functional programming and something called Petri nets, which I need to look into a bit deeper, I think. And as a result, Scala first appeared in 2004. It runs on the JVM, so a lot of like other languages that run on the JVM, there's on interoperability. I always have fun with that word. Interoperability with Java. And you can use Java libraries within Scala and vice versa. It's multi-paradigm, but what I get the impression is that they sort of push this hybrid paradigm of object-oriented and functional programming. So you get features from both worlds. And that has its own challenges as well. Personally, I suppose when I'm learning languages, I actually find it quite nice if the language in question is like a pure functional, pure object oriented, just because it forces me not to, what's the word I'm looking for? I was thinking of rest on my laurels, but just not to use stuff I'm already familiar with or try and sort of bend the language to my will. one of the problems I found here so early on is I still haven't made a decision of the best way to go with this combination of things. Like, do you go, to me, there's got to be like a sweet point in some ways, and I suppose it varies from project to project, but like a sweet point where you're looking at the best utility you can get from combining OOP with FP. Or do you just literally go, okay, this project, I'm going to just use mainly object-oriented programming for this one in Scala because it fits best, or another time I'm going to use more functional style programming. I don't really know at this point, but in a perfect world, what I'd like to do is use Scala in a way that the two integrate seamlessly, if you like, within a project. But it's too early to work out how to do that for me anyway. It's statically typed, so it ensures type safely. However, it has this type inference. So based on like inferring what sort of type a particular variable byte might be from the way the code is, it is sort of infers that. And we'll see in a moment. We'll look at that and see how that works in code. It allows for less verbose code, but at the same point, because it's statically typed, once it's inferred what that is, then yeah, that's it. The type static. So yeah, you don't get any of the dynamic typing shenanigans going on. Other things to bear in mind, you've got immutability and mutability in here. So immutable is where you can't change a value once it's set. And there's also something called case classes, which are sort of linked in with pattern matching, which are also connected to immutable data and so on. And there's mutable versions of things and immutable versions of things, which we'll talk about as well a little bit as we go through here. Higher order functions, so treats functions as first class citizens, meaning functions can be passed as arguments, returned as values, stored as variables. Yeah, so then that's something you might come across when you're using other functional programming as well. Also, there's an extensibility in the language. You can, allow the creation of domain-specific languages within the language itself. But that's nothing I've touched on yet. Okay, so we'll start off with a really simple example here. So we've just got two things going on. We're going to define a class with a method and then define a main method. This is an area I had fun and games with. Again, with this Frankenstein code, whereby this is the form for Scala 3, but you can do Scala 2 form and other variations in between, and the Scala 3 environment will still quite happily handle it. So yeah, I originally had another slide here which had 3 other examples of the main method in it, and I decided to take them out for clarity because it was confusing me. So this is the Scala 3 version. So if we break this down a bit, so the first bit that we saw, the first chunk if you like, so we're going to define this class name person. We've got a constructor here of the class person with one parameter, name, which is a string. So here we are actually explicitly saying, this is what name is going to be. And we're also defining within this class a method called greet that prints just a greeting. This is quite a good little example you can use in lots of different object-oriented programming languages. Create like a little greeter method. So it prints a formatted string to the console using string interpolation where the name the dollar name syntax here will get replaced with we'll replace dollar name with the value of the name property of the object, which we've got coming through this parameter. So yeah, so that's all set up there. It just goes hello, my name is, and then whatever name is. Notice here we've got this unit. We're printing something here. The method is doing something rather than returning something. So in this case, we've got unit here as our sort of returning value. I was led to believe it's rather like void in Java. And then our main, which is the entry point of the program. And we can have, this can be called this can be anything here. We're just calling this particular this thing run. Okay. Again, we're not really returning anything here. We're just sort of executing some code. So we're going to create a new instance of person, which we previously have. We've defined our class, and we're passing through this name Ted. So new person Ted, and here's our instance now of person. And then we can execute the code within the greet method by just doing person.greet. And so if we were to run that, and we just go back to the slide, you can probably see, hello, my name is Ted. Other sort of object structures you might see in the language, there's singletons, so you can have a singleton object with a property. So you can see I'm defining the object here. We've got our value, which we're actually defining within the object. We're not really passing anything in here. It's done inside of it, which is a string. So the value app name. And then we've got a very simple definition here, which is going to actually print that, whatever that is, and in this case it's just my Scala application. And here's the usage. It's just the name of the object and then this method here. We might come across in Scala companion objects, so we might have a class which actually has the same name as an object. So we've got our class circle, which takes in a radius, and that's a double value. And then we've actually got our object circle, and within it we have this method which calculates the area. So when we come to call it, supposing we want to have a value called circle area, which is the method from this circle object, where we've fed in 5 here into the method. So it's going to calculate the area of 5. And of course, I'm keeping this really simple. We could have a lot more methods in here. We could have a whole load of, different methods for things you might want to do on a circle. And then also here, once we've got the value, we can just print it out. And you can see again here the syntax that we saw earlier. You can also have these apply methods. So again, we're just going to have a class with person and an object of person. And within it we have this method called apply. And what's happening here, as you can see, is within this method it's actually creating this new instance of a person and returning that, and it's taking in this name and age. So what will happen within here with this apply method is, once we want to create an instance of person, it's going to feed in those values into our new instance called John, which then means by using this, John.name, John.age, which have previously been defined in this apply method, we can get those values back. And then another way you might come across things within objects and an object, and I'll go through and I'll look at these in a moment, and have a bit of a definition for classes, objects and traits. And I wanted to show you the code first. So I've kept this really simple. I could have got more complicated here, but I've just created a trait called greeter. And the thing with these traits is you can use them, you can extend them with objects. So it's like, it's this idea, I suppose, of like an interface in another language. So you're taking the trait and you're using that trait to give an interface to a particular object. So here I've extended greeter to be a bit more, have more functionality. Here we have this greeter method now, which is actually going to print out the name, which is introduced when we call this method against English greeter. So greet Alice outputs hello Alice. So just to clarify, classes versus objects versus traits. So a class is a blueprint for creating objects, instances of objects. Each object created from a class can have its own set of attributes and behaviours. Think of a class as a template for making similar things. For example, if you have a class car, you can create many car objects with different properties like colour, brand, etc. And of course that would be all defined inside of your object. But you may have things that have come originally that were defined in the class, that it's inherited. And you have objects. An object is a single instance of a class. However, in Scala, the term object also refers to a singleton object, which means that there's only one instance of it in the entire program. It's often used to hold what would be static members in other languages like functions or constants. But you've also seen there's some other stuff going on as well here, where you've got, other interesting relationships between classes and objects. And then you have this thing called a trait. So a trait's like an interface in other languages. It's a type that defines a contract of methods that classes can implement. It's an interesting turn of phrase there. Traits can also contain concrete non-abstract methods. They are used to share interfaces and fields between classes. You can think of traits as a set of requirements or behaviours that different classes can agree to provide. There's been another language, and I'm just trying to remember what it was called in there, where it did a similar thing, where you could sort of, I think of it gluing it to a thing. So you could sort of glue this, you could create these traits, or whatever that was called, and I'm trying to remember what it was referred to as, and then you just sort of associate them with objects. So here you're using the trait, and you're using it, with a where your objects are extending, as it's called, the trait. We have conditionals, not surprisingly. So I think my colour coding went a bit wonky here as I went through and tried to correct a few things. So yeah, now this is where things started to get a bit confusing when I was doing this, in terms of me balancing or moving from Scala 2, which is what the book is using, 7 languages in 7 weeks. And even in the book it references differences within Scala 2, like the different versions or subversions, however you want to think of it. And of course then going from Scala 2 to 3, there were changes as well. So I'm like literally refactoring on the fly, which I hadn't had to do since I was trying to learn Python 2 when 3 was sort of trying to be forced in. So it reminded me of that actually. So one thing I noticed was that as I modified this code, when you're moving, and of course the other thing to remember with this is it, in the Scala 3 environment I was using, it perfectly accepted the other form. And what I mean by that is, so my if clauses had brackets around them, like this sort of thing. And then these if else's, the blocks had curly brackets as well around them. Well, in Scala 3 you can dispense with that as well if you want to. And so that was the problem I was having. It's like, okay, I had to recheck all the code to make sure I didn't mess up when I was removing brackets or removing braces. So yeah, just bear that in mind. Also, by doing that, it meant that in cases in the code where I'd got like curly brackets, for instance, we were introducing then in here as well, which it wasn't required elsewhere. So yeah, but if you're used to seeing if-then statements, the other thing is that helps contribute with losing the braces, the curly brackets, is indentation. So when I started, this had both brackets and indentation, but in Scala 3 you can lose the brackets, and as long as you have the indentation then you're good to go. But you can see the sort of classic clauses, the classic one-liner, which I know isn't everybody's cup of tea necessarily. Then you've got the multi-liner, then you have the one with the else clause, and then you have this monstrosity, which is another one-liner as well. And then the full-blown if-then, else-if-then, else business. And again, in its original format, when I first sort of put this together, I had this weird, like, I suppose, Scala 2 version that would run happily under Scala 3, where it was, brackets around here and curly braces and no then. So yeah, don't be surprised when you start looking at snippets of Scala code. You may come across Frankenstein code, and that is a real problem. I don't know if I said at the start. If you're leaning into these code helpers, Copilot type stuff, I mean, I think they're great. But if you're dealing with a language where you don't know what's been hoovered up, and you've got different versions of the language that have been hoovered up to train the large language model, just really be mindful of what it's spitting out. And okay, well, it does run in the environment, as I found out, but you need to start refactoring. And probably in here, anybody watching that's familiar with Scala 3 probably is going to point out some faux pas I've made. I've tried really hard, actually, several passes now through this, in and out of my environment and correcting this. So while we're on the subject of conditionals and expressions, you can assign the result to a variable. You can use it as in a method body. And again, it's quite complicated like that. So you can see it's like taking in integers and integers coming back. The other thing is, if you've got, I've kept the examples really simple here, but if you've got one where there's like a block of code and it's returning a certain value within the block of code, it does that thing where it returns the last executed value. So here it's really easy to see what's coming back. But yeah, if you're dealing with a block of code, then yeah, it uses that technique. So there's no need, using the word result is, return is superfluous. Other things is that you can encase expressions in for loops in interesting ways. Again, just be careful. It's easy to end up with Frankenstein syntax when you're doing this, and end up combining sort of stuff that's more preferred in Scala 3 and being actually a hybrid of sort of Scala 2 type format and Scala 3, but it will still run fine in Scala 3. Yeah, so if we've got like a basic loop, so your good old basic loop is we've got a list and we're just going to iterate over the list. Yeah, so pretty straightforward for loop, and we're doing a print on our list, printing out individual values. We can use guards on this, so we can set up a thing here. So you can see here, it's only going to print out any members of the list, any element of the list where I, as it iterates through the list, is bigger than 2. Also notice in here this particular thing. So, as it's going through the list of ints, this list called ints, which is a list of integers, funnily enough, it's, each time it's assigning each element to I, and then when I do this bit, it's doing the print. You can also do for on expressions as well. You can get 4 expressions. So it looks something like this. And what this will do is you print out doubles. It's going to do this thing where it's working its way through this, doubling it each time. So you'll get this list back, which is a list of doubled items from the original. And you see yield cropping up a lot, really useful actually. Okay, pattern matching. Yeah, match and case. So you can get structures like this. So here, we've got a number of is equal to 3, and we're going to try and match that value against these cases. So this is what's going to get fired off here. So if it was 1, I get 1. If it's 2, it's 2. If I get 3, then it'll print something else. Sorry, if it wasn't any of these, print something else. Again, with case structures, just be mindful of the order. The order is obviously important because it's sort of cascading through these. And you can see here, this is like saying, well, none of the above. It's like your catching case. We can do some clever things as well. So here, and I've just got, I don't always include this in these coding examples, but there's an example of how this might be used. But you can do type matching. So I can create this function here, which I've defined. And what I can do with this is I've got anything going into it, so any type of value. There's a string coming out, and it's going to do a match here on what type of thing it is. So if it's an integer, it prints this is an integer. If it's a string, it prints this is a string. If it's a boolean, it prints this is a boolean. If it's none of these, then it's another type. And so what I'm doing here is just getting the value back. So it's going to return, you know, it's basically, so with this being 1, it's going to look at it and say, well, what sort of, you know, for describe type, what is this? Well, it's an integer. So it's that's going to come out and be assigned to here. So when I print it, it'll say this is an integer. If I had a string in there, or I had the word true, I'd get something else. So with true, it would detect it as a Boolean. And if I had something else that wasn't an integer, string, or Boolean, then it would say this is another type. I can do class matching as well, which is really interesting. So you just got a simple thing where I've just created a class called person. I've got an instance of that, which is Alice 25, based on the class definition. And you can see all the instances we've looked at here where we're creating, you know, different things. We'll come on to about val in a moment, what this means. But you'll notice here I'm not telling it what this is. I'm not telling that it's an object, you know, that sort of stuff. And here I can do a match on a particular case. So I can say, is it this case here? You know, the person match, does it match this? Well, yeah, clearly it will. If so, I'll print this out. But supposing here I'd got person Bob 35. It won't match this. If it matches this, then it will print out Bob 35. So yeah, here I can use it to match, to do what's called case class matching. And you can notice up here actually the slightly different. I've defined a case class. I'm not going to, you know, I'm going to leave out to people's imagination how you might use some of this stuff. We can do list matching as well, which is interesting. So this looks very much like, a little bit like sort of pattern matching type things you might get up to in Prolog actually. Again, the order is really important here, but I can use this to match a list. So I've got my list, and then I can say, you know, if the case is true that the list is this, then print, and then this can be anything. I mean, in this example, I'm just printing out something, but you know, I can have it do various things. Here, if the match is just on the first value, then list at least starts with 1, and then anything else it's a different list. And the thing here is important that I put this before this, because if I put this first, then this case is gonna be matched. And then I can do some guard matching with various guards, so I can sort of introduce some additional criteria here as well if I want to get a little bit more complicated. So here the value is 10, so what it's going to go through is look here, you know, is a greater than 0? If it is, it's a positive number, so it's going to print out positive number there. Now of course I might, beyond the, again here, you know, would it be useful to have a catch-all in this example? But you can sort of see the structure here once I add this guard. Whoops. How, you know, it's quite different than what's been before when I was doing other sorts of matching. There. So again, stuff to play around with. Okay, for do. So yeah, single line, which I think we've seen already. That's the sort of classic single line. So you can get into some interesting multiple line constructions. And again, you know, I had versions of this with braces and various other things going on and brackets around some of this. But what I've found in Scala 3 is there is a tendency to sort of do away with superfluous stuff. So instead of using curly braces, you know, indenting stuff, and so in some instances, and you have to be a little bit careful if you don't start removing brackets around things left, right and centre without obviously checking that it works correctly without them there. But yeah, I can do stuff like this. So I can do a for loop whereby I set this condition up where it'll only do the do bit here. Now again, I can play around probably with some of the indentation a little bit within reason, and the environments that I worked in is pretty good, which I did a video actually of how to set up a Scala environment as part of what was it? I'm trying to think of my series, the IT wildcard, and that's what I use for this. Yeah, so in this example, what it's going to do is simply print out. We've got the modulo here. It's just going to print out even numbers from this list, and then I'm using an N4 here just to improve readability a little bit, so it's a bit clearer. But like I said, you can lay this out several different ways using more Scala 2 type code, and it'll still run fine in Scala 3. Under Scala 3. So yeah, this interesting yield thing that we saw earlier. So here I'm generating squares, a list of squares. And it will, if I print this, I'll get the list, but with as squares, because I've created this new list. And a very simple while loop. I decided with this particular episode to keep things really, really simple, because yesterday my brain was really scrambled and I was having serious thoughts about actually pulling the series because I was so confused. So yeah, I've dropped out a lot of stuff I'd normally talk about. Sometimes I'll do like variations on while loops, and some of the algorithms I've waved away, done a wavy hand business on them, because things were getting very confusing. Trying to decide what's the best way to present certain things, and I was ending up with multiple versions of the same thing. So yeah, I decided to keep it simple. So yeah, this is one of these countdown while loops. So while y is greater than 0, do, it's just printing I out each time, and then it's got one of these cool like compound expressions where it's basically taking I, which is 5 initially, and then taking 1 off of it each time. Okay, so funnily enough, we get on to operators. So yeah, usual suspects, but we might as well go through them. So yeah, addition, adding 2 operands, subtracts the second operand from the first, multiplications here, division, modulus, yeah. Pretty straightforward, and obviously you build up these arithmetic constructions in all these languages. So these are the basic building blocks for that. And we've got relational operators, so the usual crowd, equal to, not equal to, greater than, less than, greater than, equal to, less than or equal to. Logical, logical and, logical or, logical not. Assignment operators. Again, a lot of these you'll recognise if you worked in other languages. So yeah, add and assign, subtract and assign, multiply and assign, divide and assign, modulus and assign. They're all in here. Precedence. So yeah, I'm still getting my head around this, but it goes something like this. So when an expression uses multiple operators, the operators are evaluated based on the priority of the first character. I haven't seen anything weird happen so far, but this is the precedence table. It's got characters not shown below. I took this directly out of this is directly from the Scala document. Okay, so yeah, blame the Scala document. So yeah, I mean, pretty much the usual order we're used to. And then we've got all letters, dollar, and that underscore symbol. So yeah. And here's an example, you know. So if we add the following expression, if we use, you know, brackets here to just show you that what that's equivalent to, in this example and in this example, question hat, whatever you want to call that, has the highest precedence because it starts with this character, plus as the second highest precedent followed by other characters. So what all it's saying is, in this example, this is equivalent. If we and sometimes I'll actually do that in code. I've done it before where I've often used brackets in equations just to really hammer home the precedence. Comments, yeah, single line, multi-line, the usual things. As abstraction, so I'm going to talk a little bit about abstraction here. There'll be a few examples, but it's a bit talky at this point. So, not much code, I don't think. Abstraction is the process of hiding the implementation details of a system or a component and exposing only the essential features or functionality of the user. Abstraction helps to simplify complex code, reduce duplication, and improve readability and maintainability. So in Scala, we've got abstraction through OOP and FP and other things as well, I'm assuming. I'll get on to some code in a moment, but just again, you know, objects, classes, traits. So you've got this abstraction through using objects, because we're encapsulating your utility functions or constants without needing to create yeah, did I word that right actually? To create instances of a class. Yeah. So we're creating, yeah, but I think I've mangled my wording a little bit there, but basically my point is that, you know, you can, within Scala, because we've got OOP, you can use objects as a way of encapsulating stuff, which aids abstraction. So classes aid abstraction because they're blueprints for creating objects. They encapsulate data and behaviour that belongs together. So you can sort of define a contract for what an object can do without necessarily exposing how it does it. And then traits, a bit like interfaces in Java, as I've said before, but you can contain, you know, concrete implementations in them as well. So they're used to define abstract interfaces that other classes can implement, but they can also provide default behavior. So, you know, my point is that in Scala, because you've got access to objects, classes, and traits, you have a means of abstracting things. So that's one way you can abstract things. Also, we've got access to functional programming, so we can abstract things through higher order functions, which take, you know, other functions as parameters and return them as results. This enables the creation of very generic and reusable code blocks. I mean, just also, I don't know if it's specifically mentioned here, but just the functions we've looked at already. You know, so the basic functions we've looked at are ways of, you know, abstraction. But I'm talking here, I suppose, about things specifically that turn up when you talk about a language that's a functional programming language. So we've got function types. You know, the whole thing of basically, you know, passing around, you know, values. So this sort of concise syntax, which just helps a little bit to facilitate value passing. You're passing functions around as actual values as well. You've got lambda expressions, another way that you can do it. So without giving it a name. Partial functions, some of these we're going to look at code examples in a moment actually, by the way. Currying, you can transform into like a series of functions, each with a single argument. And we'll see an example of that in a moment. And then implicit functions as well. So yeah, all the function goodies. So just a few examples here. So yeah, within OOP we can define a trait with an abstract method. We can define a class that extends the trait, provides an implementation, and then we can define an object that uses a class. And all these are means by which you can create abstraction in a language, specifically in Scala. With functional programming, we can have these higher order functions that take a function as a parameter. Easy to see than describe. We can have anonymous functions with the higher, so here's an anonymous function with a higher order function inside of it, or with a higher order function, sorry. So here's the anonymous function here going on. And then we've got some partial function stuff we can do. We've got an operation on numbers here that does a multiply by 2. And then we have currying here. So in this example we have carried out, so a plus b underneath this, but we're currying it here. So we've created this add 5 from our original here, our original function, or our original function. I'm probably getting confused here between functions and methods, thinking about it. But then you can see here I can then use this. So I've got this clearly here, the version here actually takes 2 values, but I can implement it in a way through currying where I've got this add 5 which is taking one of the values, and then I provide the other value later when I use this add 5. So yes, I don't know how clear that is about what's going on. Okay, so I thought about, this whole business of methods or functions when I was thinking about the language. So, and we'll come on to a code example in a moment, but we've got methods. So methods are part of a class or object, defined with the def keyword within a class trait or object. Methods can be parameterized with type parameters and can have default parameters. They can be overloaded. But my understanding is they can't be passed around as values directly. However, they can be converted to functions through a process called eta expansion, I believe. Functions are objects and instances of function n traits, where n represents the number of parameters they take. They are first class citizens, so you can assign them to variables. We've seen that. That's where I get a little bit confused, because in the previous example, we're like assigning stuff to variables here. store them in collections or pass them as arguments to other functions. They can be defined as literals using that sort of syntax, and they can support higher order functions, so they can take other functions as parameters and return them as results. So if we sort of here, you know, we've got a method inside a class which is multiply method, and here's the sort of equivalent as a function, as a value. And so if we wanted to use the method one, and it looks like this, because we've got to obviously, you know, we've got a class called mathsops, so we actually have to generate our, or we have to create our instance, and then we can take that instance and invoke, apply, however you want to think of it, the method on it. That gives our result method. With the function, it's just a question of doing this. But you can see in the two examples that the differences between the two here. And of course the fact we've got this inside of a class as well. And when you're doing this obviously and you're using like code highlighting, it looks different in the Visual Studio Code with the appropriate code highlighters enabled. Yeah, I thought I'd give this a go. This proved to be a little bit more complicated actually. So I don't know quite what happened here, but when I switched from using or making it more of a Scala 3 format, it sort of broke, and I had to introduce this. So this lazy, what do they call it? Lazy values. So originally it didn't have this, and it had curly braces around it, because you can see they're very similar. Like, you know, there's the method for the factorial. Here I haven't actually got it inside of an object, just wanted to show you like the basic code. But you can see here it looks a little bit different, doesn't it? So this is the method version, this is the function version. But the underlying code you can see, and we're using recursion. And this was my downfall. So this ran fine once I implemented it correctly, as part of an object. But when I came to do this one in its original form, I got an error about where was it? Forward reference extending over the definition of factorial function. But when I looked it up, it said, oh yeah, you need to do a lazy evaluation on this. And as soon as I did that, create a lazy value, yeah, problem went away. So I was good to go. And just here, just to clarify, so the factorial functions used directly since it's a function value. So if you were to use that, well, the factorial method is a method that you would typically call on an instant of a class or an object it belongs to. I opted not to show it in situ because I was just interested in like how the actual, you know, the definition, if you like, of a the same thing, but you know, doing it as a method versus doing it as a function, just looked within just the definition. And so both of these do the same when they're implemented in the appropriate way. But yeah, so this is something that's definitely worth researching, I think, and I need to look in a bit more because this was a bit of a last minute fix. Like I said, when I ran the code in its original Frankenstein version, it seemed fine a day or so ago, but as soon as I start refactoring based on sort of Scala 3 aesthetics and other things, yeah, that's when it broke. So I don't know really exactly what was going on there, but yeah. Okay, so full disclosure, I thought it was easiest to actually just have these from the language tool, and I'll include a link to this in the notes, as I will other things as well that I think are going to be useful. So yeah, I haven't really talked about types that much. I've sort of done a wavy hand thing a little bit, saying, well, it handles types. You've got static typing with inference, and there's this. If you check this out, I didn't include it here, but there's quite a good diagram that sort of lays this all out. But just descriptively, so you have this supertype of any, which is a supertype of all types, also called the top types. The top types. So think of it like a tree, up the top of the tree. At the very top, expanding down. What's this sort of downward tree? It defines certain universal methods such as equals, hashcode, toString, and has two direct subclasses, any val and any ref. So any val represents value types, and there's 9 predefined value types. They are non-nullable, so they're double float, long, int, short, byte, char, unit, boolean. Unit is a value type that carries no meaningful information. You saw me using that, where I was sort of defining things where I didn't need any meaningful value information returned. It was because the method or whatever was a function that was doing something, but it wasn't returning a value. There's exactly one instance of unit which can be declared literally like so. Brackets. All functions must return something, so sometimes unit is a useful return type. Yeah. So that's why, because functions have to return something. Any ref represents reference types. All non-value types are defined as reference types. Every user-defined type in Scala is a subtype of any ref. If Scala is used in the context of a Java runtime environment, any ref corresponds to java.lang.object. Nothing a null. Something else we've wavy hand away a little bit and mentioned so far. So nothing is a subtype of all types, also called the bottom type. There's no value that has a type nothing. A common use is to signal non-termination, such as a thrown exception, program exit, or an infinite loop. I'm not going to talk about exceptions here. It is really important in a language to learn about exceptions, but I've sort of skated around them in I think most of these episodes. So null is a subtype of all reference types, i.e. any subtype of any ref. Has a single value identified by the keyword literal null. Null is provided mostly for interoperability with other JVM languages and should almost never be used in Scala code. That's an interesting point actually, because I know that's the case in other languages that use like a virtual environment. Often you'll find that the main language that was first on the scene in the particular virtual environment had like null. And so as a consequence, because of interoperability reasons, it has to be there, but you just don't use it. Inference and static typing. So type inference, Scala's compiler can deduce the types of the variables and expressions without explicit type annotations. And this allows developers to write code more concisely, as you don't need to specify types explicitly. There are instances where you do need to do that, and we saw, in certain definitions like methods and functions. So, but here you can see this sort of example. We've seen a few of these where I'm just, creating a value, x equals 1. Scala infers that x is a type of int. Static typing, despite the flexibility offered by type inference, Scala is a statically typed language. It means the type of expression is known as a compile time, which helps catch many errors early in the development process. Static typing ensures that once a variable is declared with a type, you can't reassign it to a value of a different type, which then conveniently leads into mutability and immutability. So you have this idea in a lot of languages of mutability and immutability. So, but the good thing is in Scala you get these collections of libraries which include both mutable and immutable versions. So in an immutable collection, once it's created, you can't change it. Any operation that appears to modify the collection creates a new collection. Mutable collections allow in-place modifications such as adding, updating or removing elements. You can see where that's important in things like lists and queues and various other things. By default, Scala uses immutable collections. So for example, if you're using the collection set, then and you use it, it assumes you mean immutable.set unless you specify otherwise. So you can do that and it assumes that. And then variables, so you get mutable variables var and immutable val. So probably in some of my previous examples, I was, I think in a lot of these I have been using a val. So Scala allows you to declare variables as either mutable or immutable. Val is an immutable variable, meaning once it's assigned, its value cannot be changed. And var is a mutable variable, which allows the value to be changed over time. This is always the preferred option. Yeah. And I have worked in languages like this before. I've dabbled, like I know, was it Clojure was the first time I sort of got properly exposed to it. I mean, you come across it, you may have just not been aware of it before, because maybe in the language you've been using, the default was mutable for a lot of things. So it's only when the default tends to be immutable, well, that's the direction it's pushing you in, that it becomes a thing that you need to think about. Strings. So in Scala, like Java, once you create a string, it can't be altered. Any operation that seems to modify a string creates a new one. String operations. Scala provides a rich set of methods for string manipulations, including comparison, concatenation, and searching. And there's common operations that you can do. And we've seen string interpolation as well. So that's where you've got, these embedded variable references. Using like dollar and then the name of the variable, and you've probably seen they were prefixed, the bit of the string that you needed to interpolate had s in front of all the ones I was using, but there's f, sf and raw. So s allows the use of variables directly in the string, f allows formatting, and the raw is like s but it doesn't recognize escaped literals, which again I'm wavy handing away a little bit. There's a lot of wavy handing going on in this episode because there's just so much. I mean, it sort of blew my mind, and there's a really steep learning curve to this language for lots of different reasons. So just be forewarned. Yeah, string equality and regular expressions as well, not surprisingly. Yeah, so here's some examples. So let's get back to some code. Single string, multi-line. This is interesting as well. Just be careful. The reason why there's all this strip margin shenanigans going on is because if you don't do that, it literally assumes that these are spaces. And that can cause a problem when you try and print it out again. It doesn't. You run into problems with alignments. So this is the way you do it with this sort of new line indicator. You might have seen this come up if you've been using the REPL. If you've ever used the Scala REPL, when you sort of go multi-line, you get this. But yeah, this is the way you can do multi-line strings in Scala. There's concatenation using the plus here. So I'm just concatenating this to this. Interpolation we mentioned. So again, just trying to show you some code examples of stuff I've verbally intoned. So there we go. There's a good example there. And then good old regex. So yeah, you will need to import the regex library. So if you've ever done regex in the past, it's similar in a lot of languages, and you have to sort of create this regex object, and then you do these various methods on this object. So, you know, here we've got our regex object, which is defining our sort of pattern matching thing we want to do. We've got our test string, and then we're, you know, against this sort of regex pattern doing this method to find, you know, a yes or no, if you like, true or false. Good old lists. So yeah, creating lists, pretty straightforward. There you go. So we got our fruit, which is a list of strings. Here we've got a list of integers. Here we've got a list of nothing. If we feel so inclined, that's our empty list. Again, notice here certain syntax things going on here. We're doing a lot of osmotic learning, I think, in these episodes, where sometimes I don't always pointing out some of the syntax things or the sugar that might be going on, syntactic sugar. Yep, so we can access elements using actually head and tail. So if you're familiar with my episode on what was it? Prolog, you've probably seen this concept before. So, you know, supposing we take fruit and we say, oh, I'd like to create a list. Well, actually, it's not a list, it's just a head. So the head is apples. The remaining fruits, which is a variable I've got here, is a list of the remaining items. And of course, what's happening here is that on the fly, Scala's like working out what sort of thing, what type to make this variable. But I can also access elements like this, the sort of classic way. I can do pattern matching, so I can pattern match my fruits. Here, this is an interesting way of doing an empty list. There's probably multiple ways of doing this. But yeah, I'm just saying, you know, basically, does my list have a head and tail? If it does, then print the head and the tail. If it doesn't have a head and a tail, then the list is empty. So in this case, it would print head as apples and tails as oranges and pears, based on the data. I can concatenate lists. If I do this, it's more of a prepend, I suppose, where this symbol here prepends a single element to a list. And notice here I'm assigning a new variable, a value of list. And we got lots of fruit, which is our original list fruit, and then the list. So fruit was on the previous page, if you're wondering. I think, have I got that right? Yeah, there we go. So we've borrowed from the previous page. Lots of fruit we defined, more fruit we defined up here as being our original fruit list plus bananas. And so we end up with this: apples, oranges, pears, bananas, apples, oranges, pears. We can do like list functions where we can create sort of maps of a list. So here what it's doing is going through fruit and working out the lengths and then creating a list which is the lengths of the different values within that fruit. And then we can do things like filters on our fruit, on our list. So we're filtering out anything where the length is less than or equal to 5. So here I'm sort of using this as a placeholder as it iterates through the values of fruit. And I'll just clarify here, so 2 colons for prepending single item elements to a list, and then 3 to concatenate 2 lists. Yep, more lists to do with for each. So I can create a list. Now here you'll see in a moment we've got a slight change, because this one I do want to start changing the value. So this is a immutable up here, value. So we've got a list of numbers, 1, 2, 3, 4, 5. We could do a for each, which would print each of the numbers in the list. We can do a for each, which would print and double the numbers on the list. So here, because I need to calculate something, I'm using num here as my, place, my holder, if you like, for that. I'm assuming I might be able to use just the underscore, thinking about it. Possibly. Depends, I suppose, whether I want to use that number elsewhere. That when we talk, there's another language like that where it's like, well, do you actually want to use this somewhere else in the calculation, or on the line or whatever? So yeah, so here we've got double, and then we can do conditional printing with this monstrosity. Yeah, for even numbers, and then summing. So here, because we want to be changing this sum value, we do want to make sure that sum is a var. It is mutable. Otherwise we're going to run into problems and get errors. So here we're doing a for each, and we simply have this placeholder for each of the values as we go through them, and each time it's adding them to some in this cumulative thing, and then we print out sum. So it's going to be the sum of this, basically. But I'm sure there's also, functions that can do that in a single hit, don't forget. Other data structures, I'm just going to mention these in passing. I'm not going to go through necessarily all, I don't think any of these, because there's just so many of them, but ones to investigate. So there's different immutable collections, so vectors. We've got sets, we've got maps. Vectors, I understand, are good for fast random access. Sets are a collection of unique elements without any order. And maps are the key value pairs where each key is unique. Mutable connections, array buffer, list buffer, hash map, and I think that's it. There could be other ones as well. Specialized ones, we've got stacks and queues, LIFO, and the other way of doing it. And then linear data structures like arrays and linked lists. But I'm sure there's other ones as well. Ranges, yeah. So various ways we can, leverage ranges. We can create just something that has an inclusive range, like this. So that's now going to contain that. We can create a list from a range. We can create an array from a range. We can create a set from a range. There are methods that you can do on ranges. We can create even numbers from a range by going up in steps of 2. We can do alphabetical ranges, creates from A to Z, reverse ranges and decimal ranges. Actually, I took that out, I think, because that didn't work. So scratch that last one. I've had to, I think this was the one where didn't quite, again I refactored it and didn't work very well. So yeah, that one ignore. Okay, I thought I deleted it out actually, but obviously I must have forgot to save that part of the presentation. And then you can do these nifty sort of one-liner range shenanigans if you feel so inclined. Okay, let's finish off with a few final things. So writing to text files, there's multiple ways you can do this. I'm not saying this is the best way, but I just wanted to get you a feel for how you can do it. So this way, we're basically using print writer. So we're actually importing that from the Java library. Yeah, so we've got we're just going to create this new print writer object, which is this object here, which is going to be pointing, I suppose, I'm trying to think of a good word for this, but this is the file name here. So you can see we've got, objects inside objects, or creating instances inside of instances. So this new file instance example.txt, which itself feeds into a new print writer instance called PW. And then I can write PW and I can close it. So I'm just writing hello Scala. But I can also use this thing called file writer and buffered writer. It does apparently give you more control. I don't know exactly why at the moment, because I've just wanted to show a couple of examples, and these both work well. But there's certain ways you can do things in Scala where you can get more control over things, and I believe that file writer and buffered writer enable you to do that. But in this example, because we're dealing with a pretty straightforward example, we don't need to do anything super complex here. I'm assuming, or I could have, I just wanted to split this down a little bit so I didn't get too over the top, but I could probably have done this inside this actually as well, I suspect. I've kept it fairly simple for reading. Just one example here. So this one, just to again add a bit of variety, I'm using the Scala library to do this one. So this is reading a text file. So a bit more stretched out here. See what's going on. So we just got a file name of example.txt, and we're just feeding that into this source.fromFile, which we've got from our library, which is a buffered source. Well, that's just the name I'm giving, but it is a buffered source. And then I'm reading the thing line by line. So for each of the lines, it's coming into this variable, so going through, and it's just I'm just printing out here. I could be doing something else here, processing it. On this one, in this example, you can see I've still got these. I did test it without them, and it does work. So yeah, I kept the brace, but this is what this looks like with those braces in. But because of the way Scala 3 works with the indentation, you can actually lose these as well. But you have to keep this. Okay, if you remove this, then you get an error message basically. So, yeah. And don't forget to close the source. The other thing with this, and again I'm being a bit sort of, these are a bit quick and dirty solutions just to show you the a example of things in the language. You would probably want to do some exception catching here, because if this failed before you closed it, you could run into problems. And again, there's other libraries that maybe do that more elegantly as well. And then I always like to finish off with a simple input and output to the console, because over the years I've done this so many times in different languages, and it's really good to just know how you do this. I'm using this scala.io.standardin.readline. So just printing out, please enter your name. Here in this one, it's rather like other languages where this way it's just going to wait at the end of the line. Whereas this one's doing a line new line return. So yeah, so it's going to sit there. I type in whatever it is, my name, and then it's just going to print hello and my name. Of course, again, we're keeping it really simple here. So there's all sorts of exception handling and defensive programming, those sort of things, which need to go in if you're actually building stuff for in production use. But this just illustrates some simple coding structures to just get you familiar with the language. So some stuff to try. Well, there's lots of stuff to try. You could try. I haven't touched on Scala build environments, so yeah, I definitely explore that. You definitely need, I think, with Scala to go down a functional programming rabbit hole, an object-oriented programming rabbit hole, and just see how they work best together. There's also reactive programming stuff you can do, parallel programming you can do in the language. There's also this big data thing with Apache Spark and Scala, which again I've not really mentioned. So, knock yourself out. But again, comes with a word of warning. I do find this language has a really steep learning curve, but also there is potential for Frankenstein code. So just be mindful of that, and just make sure whatever you choose to do, and because I was learning the language new, never touched it before, I just thought I'm going to just learn Scala 3. And download that version of it and install that version. But just be mindful that, you have to really think through on what is the most idiomatic version of the code for the particular version of Scala that I'm using, and sort of try and go with that. So remember to check out my Scala files, but again, they come with a warning. I have created an actual sandpit file for this episode, but it's got lots of code snippets in it that I'm going to be revising over time. They run fine as snippets if you sort of take them out and run them within the correct sort of environment within main or whatever, but do be mindful that they are very Frankensteinish in nature, because I'm still in the process of sort of switching between 2 and 3. So yeah, just word of warning. I'm going to have links to other resources. If you find this series useful and you think others will find it useful, please share it. That should have enough information to get you started. So now it's time to code to learn. I don't know how much I've sort of discouraged people from learning this language. I hope not. And if you're already familiar with Scala, please chime in the comments section and offer your own pearls of wisdom in terms of wrestling with the whole Scala ecosystem as well, because it would be really useful to hear. So thanks very much for watching. Bye for now, and I will catch you in a future episode.